Hello friends, Global Vision with you, and today we're gonna talk about fractal cross type antennas. And today we're gonna talk about another type of antennas we had in our past, another type of free energies antenna. We all have seen it, but no one can explain why we have this type of antenna and how it works and what kind of antenna it is. Actually, today I will try to answer all those questions and we will try to understand how this all worked and what frequencies and so on. But before we go into the details, deeper in the details, let's talk about how can we improve the frequency and parameters of normal antenna. We can use Koch algorithm, Koch quadrant or Koch triangular, and we do it by this. We cut it into two parts, one line into two parts, and add the same line, the same length of the line into the middle.
Each time we add a triangle, one side of the Koch snowflake will turn into 4. After the first repetition, we'll get 3 times 4 to the first, or 12 sides. After the second repetition, we'll get 3 times 4 to the second, or 48 sides. After repetition number n, we'll have 3 times 4. Regular antennas have to be cut for one type of signal, and they usually work best when their lengths are certain multiples of their signal's wavelength. So, FM radio antennas can only pick up FM radio stations, TV antennas can only pick up TV channels, and so on. But fractal antennas are different. As the fractal repeats itself more and more, the fractal antenna can pick up more and more signals, not just one. And because the perimeter of the Koch snowflake grows way faster than its area, the fractal antenna only takes up a quarter of the usual space.
But it depends. In reality, we cannot make it smaller than shorter than first initial wavelength. So its starting wavelength is big, we need bigger size. So we don't know what frequency we use, but we can state that we had free energy fractal antenna and the first preliminary wavelength was pretty big, and then it was the lowest frequency was pretty big, but the highest frequency was, insane, infinite. What we do, we just take a normal antenna, normal line, and then we use fractal as much as we can, as many times, triangle, double, and so on. But triangle Koch is not the only fractal. We can use quadrant, Koch quadrant, also well-known way to improve frequency and parameters of antenna. How we do it? We cut it into 3 parts, and in between, in the middle part, we add not two lines, but 3. So we have something rectangular. And then we do it again and again. We add 3 parts into the middle, into the place where we break it. So we can either improve parameters or make it less, smaller, again and again. And as you see, we had frame antennas with many additions and repetitions, iterations of Koch quadrant or Koch triangles. And now, when we know all this, let's try to make cross-kind fractal antenna. And when we understand it, as this guy say, we are like monkeys today compared to what we had today. It's a normal frame antenna, but look how beautiful it is. I insist, it's free energy frame antenna we had in the past. Just imagine. It's hard for me to say in technical English, but you got the idea. I can prove you easily in Russian, but in English, just get the idea. All we need to find out the initial wavelength. That's it. And then we will realize how this works. Fractal antenna or phase array antenna. All these are huge antenna. Why it's huge? Because of the initial, very first wavelength, the lowest wavelength. And just look. And then we use the same algorithm to create a quadrant of Koch quadrant. But we also can use different kind of making fractal antenna. Sierpinski quadrant. It's also made on normal printed on surfaces, flat surfaces. We can use also Pian, Gilbert, Koch, Sierpinski, and other algorithms and so on, ways to improve our fractals, our antennas. And even more, moreover, we can use different ways, better ways. Krest-Koch or Sierpinski ways, fractal. What we can do? We can put away middle path. From the middle path, the same crosses, we move it from middle path to the ends. And we can use very good, we get very good antennas. But we can use not 90 degrees angle. We can use other angles and other ways of placing antennas. We have so-called tree antennas. It's space volume 3D antennas with very good parameters of accepting signal and energies. But fractal antenna we can use with small kind of antennas. Their parameters and sizes less than wavelength, but this cross antenna, this type of antenna is also small, much smaller than not fractal. But there is another way of using space, much more efficiency. And there are many other ways of making fractal antenna. Gilbert, Kian, and even meander antennas can make and can let us use space with highest efficiency. And if we know that we have standing waves everywhere because all cities were inside star forts, all cities absolutely, and we can make energy from any space, and if in meander we can use very simple way to make rotation, torus, we can make toroid in one place, Lorentz place, one Lorentz force meets another Lorentz force in meander, like in swastika in meander, and we can make toroids. All we need, just not necessary make it made of metal. We don't need metal, but we can cover it with some metal paint, and we will have rotation toroids everywhere in standing waves, in any frequencies. So we had dense space everywhere, full of ether, argon, whatever. I wouldn't call it electricity, but we can get this energy for different purposes. All we need to draw some bas-relief, some even painting, and it will work. And let's sum up. How can we use it for heating, lights, and so on? We can make antenna very simple way. We can take normal frame antenna, then add some iterations in between and to increase frequencies and so on. Cross-kind antenna like a frame antenna with some iteration added. Koch quadrant or Koch triangle. So there are many fractals with very efficient way of using space. I think that's it for today, and share, comments, like, and ask what else you want to know about our ancient antennas and free energy. Thank you for your attention. God bless you. Bye.